We've looked at how to condense logarithms. Now we can go the opposite direction and expand logarithms. So when you're expanding logarithms, that means that there is no multiplying or dividing or powers in the argument. Okay. And then condensing, I guess we can just write this right here. Your condensing was where you're just writing it as one log, which means that there is no adding, subtracting, different logs. I mean, multiple logs, I should probably say. And no multiplying in front of logs. So that's what we mean by condensing. You want to write it as one log, so you don't have any any adding or subtracting, so you would rewrite it as multiplying or dividing with the arguments. And you don't have anything being multiplied in front of the logs. Here, you go the opposite direction. There's no multiplying, dividing, or powers in the argument. Okay? Remember, the argument is the thing after the log, the of part, log base of, that's the argument. Okay? So here, if you have power, your power can be moved to be multiplied out in front. Remember, you can make a dot with your two fists and then split it so that one is being raised, or I did it backwards, where you have your fists where it looks like a thing being raised to a power, and then you make it into your two fists next to each other, so it makes a multiply sign, so it's being multiplied. So you have 2 log base 3 of m. Here you have the argument, these two things, the q and the r, being multiplied. So with multiplying, you can make a cross, an x for multiply with your arms, and then you tilt it sideways to remind you that it goes to plus. So I can split this to 2 logs and write the product as being added with the 2 arguments of the log. So log base 7 of q plus log base 7 of r. Okay. When we're dividing, you can do divide goes with subtract. So you move your arm so it looks like a divide, and then you tilt it sideways to get to a subtract. So this is log base 1/4 of p subtract log base 1/4 of n. Okay. So those are our 3 properties. Now we can use them with more than one of them. Now yesterday we talked about, or the other day we talked about how if there's a positive in front of the log, it went to the top of the fraction. If there's a negative in front of the log, then it went to the bottom of the fraction. Well, you can do the same thing here, but backwards, right? So this is in the top. Notice there's just an unsaid 1 here. So both the n is in the top and the m is in the top. So that means that in front of that log, it will be positive. So log base 6 of n, and it's a positive out in front. And then because the power is 3, that gets moved out in front of the log. And then since the m is in the numerator, it would be a positive in front of log base 6 of m, and then the power gets put in front of the log to be multiplied. Okay. And then you don't actually need this positive sign that you have out in front. You do need the 3. You need the positive one here to show that they're being added. Okay. If we look at this one, I first need to switch any radicals that I have, any roots, to be a fractional power. So this will be log x cubed y squared over z to the 1/2. Remember, our property is that if you have a to the m over n, it's the same thing as the nth root of a to the m. So the denominator is the kind of root, the numerator is the power. So this is really the unsaid square root of z to the first. So that's how we get to the 1/2 power. Okay. The x is in the top, so that means that there's going to be a positive in front of that. Log, there's no base, so of x. And then the 3, the power goes out in front. This is in the top, so it's a positive log y, and then the 2 goes out in front. This is in the denominator, so that means it's a negative out in front, log z, and then the 1/2 becomes multiplied out in front. So you could write it like that, or this would also be acceptable. where you do minus log base z, or not base z, log of z divided by 2. So either of these would be fine answers. Again, you don't need that positive there. That's just to help show my thinking of this was in the top, so it's positive. So here, try this one, see what you can get, and then check it. Again, it's really important that you're trying these on your own because it helps to try things on your own. It's easier to see how someone is doing it when they're doing it, but trying it by yourself is different. So it's always good to practice yourself. Okay. The P, Q, and S are all in the top. So that means that all of them have a positive in front of them. So natural log of P, but there's a 5 out in front. And then natural log Q is positive because it's in the top. And then the power is 3, so the 3 goes in front of that. Plus natural log S, but the power is 2/3, so 2/3 goes out in front. The n is in the denominator, so there's a minus out in front, so minus natural log n with a 2 out in front because of the power with the n squared. And then minus because the m's in the bottom, so natural log m with a 3 out in front. Okay? And then this becomes your final answer. You could also choose to write this part as 2 natural log s all divided by 3. This is another, this is another equivalent way that you could write this portion, but the rest of it needs to be there. I know this is all expanded because there's no multiplying, dividing, or power in any of the arguments. And that means that I'm done. Okay. Now here on this one, I want to make sure that I switch these to fractional powers, and then this one, I'm going to raise each one to the power first so that I can get inside the argument simplified first. So I have log base 4 of 3. This will be x to the 1/2. And then y to the 3/2, because the power is 3, but it's a square root. All over, when you have a power raised to a power, you multiply. So 2 to the 4th, n to the 4th. Okay. So if you have things being raised to a power, I raise each one to the power before I expand it so that I can get everything, all the stuff correct. You can do it the other way as well. I'll show you that in just a second with maybe the next one that we have. So here, the 3, the x, and the y are on top, so all of those are going to be positives in front. So log base 4 of 3, there's no power with 3, so plus the x has a positive, or is in the top, so it's positive out in front. And then the power is 1/2, so that goes in front of that log. And then since y is in the top, it's positive, log base 4. Oh, I forgot my base of 4 over here, don't do that. Log base 4 of y, and then the power is 3/2, so that goes out in front. The 2 is in the denominator, so it's going to be minus out in front, so minus log base 4 of 2. The power with 2 is 4. The n is in the denominator, so it's going to be negative out in front, log base 4 of n, and then the power with n is 4, so that goes out in front. Make sure you're not forgetting to write the base with each thing. That's something I'll see have happen and there's just no x or y value. So make sure you're writing the base still in the argument spot, and then the power goes out in front. Okay. So then this is our answer here. I could have, let me show you if I give you something like log base 5 of x squared y cubed to the 4th over 2 n squared p cubed to the 2nd. So here we could do, these are in the top, so we're using both of these because they're being raised to the 4th. So these are in the top. So I split it so that it's log base 5 of x squared y cubed, but the power is 4. This is all in the bottom, so it's negative out in front. So minus log base 5 of 2n squared p cubed with a 2 out in front because this was the power. But notice here, we still have these two things being multiplied. So I have to split this log into two other logs, but I have to keep that 4 out in front. So then I'm going to do 4 log base 5 of x, but the squared, that's this power, gets multiplied out in front by the 2. So the 2 times the 4 really gives us 8. And then I would do plus 4 log base 5 of y, and then the cubed of this power really gets multiplied out in front. And then here we've got these 3 are being multiplied, so I need to split them. So I'm going to keep the negative with each one of them because the negative 2 is here with this log. So we would get minus 2 log base 5 of 2. With the power of 2, there's 1, so I don't need to do anything extra with that. With the n, we would do minus 2 log base 5 of n squared, but the squared power gets multiplied out in front, so we have times by 2. And then I have minus 2 log base 5 of p, but the cubed power goes out in front, so I would really be timesing by 3 here. So then when I simplify that, that turns into 8 log base 5 of x plus 12 log base 5 of y minus 2 log base 5 of 2 minus 4 log base 5 of n minus 6 log base 5 of p. Now, if I had raised each one of these to a power first, at the very, very beginning, I would have log base 5 of x to the 2 times 4 is 8, y to the 3 to the 4th is 3 times 4, which is 12, over 2 to the first squared is 2 squared, because we're doing the 1 times the 2. Squared times squared, or n squared to the squared is n to the 4th. P cubed to the 2nd is p to the 6th. So then notice, with our power in front of the x, it should have an 8. In front of the y should be a 12. In front of the 2 should be a 2. In front of the n log 1 should be a 4. In front of the p should be a 6. These 3 were negative because they're in the bottom. These 3 were positive because, or sorry, those just 2 of them. Those 2 were positive because they're in the top. So you can do it either way. Both get you to the same spot. Personally, I kind of like this way better, but they either get you to the same thing. And that's how you expand your logs. And then you check and make sure in your arguments you have no multiplying, no dividing, and no powers. And that's how you tell you're done.